Hello learner, welcome once again to Manifested Online Classes. We are going to proceed ahead with our topic on similarity and enlargement. In our today's lesson, we are going to talk about volume scale factor. So, our today's lesson is volume scale factor. At the end of the lesson, as the objective, the learner should be able to understand what volume scale factor is and also use the knowledge gained to solve problems. So the objective is to enable the learner to understand volume scale factor and use the knowledge to solve problems. So to get a better understanding of this, we shall look at two similar cubes. Two similar cubes. Cubes, or in this case cuboids, 5, 2, 3. So learner, on the board, there are two similar cubes, P and Q. So you say cuboid, P is similar to cuboid Q. So from our linear scale factor, we can get linear scale factor, linear scale factor. Our linear scale factor, you can divide the corresponding side. So it's 5 over 2. 5, not 5 over 2, 10 centimeters over 5 centimeters, or 4 centimeters, divide by 2 centimeters, learner, 2 centimeters, or still you can take your 6 centimeters, divide by 3 centimeters. So we get our area scale factor, our linear scale factor is 2. We can still come and get our area scale factor. Area scale factor. Area scale factor, in each case, area scale factor, you can take the base. You can take 10 centimeters times 4, divide by its corresponding plane. So it will be 10 centimeters times 4 centimeters. And I'll divide by its corresponding plane. This plane corresponds to that. So I'll divide by 5 centimeters times 2 centimeters. If I work out that well, learner, I'll get 40 centimeters squared, divide by 10 centimeters squared. That works to 4 over 1, which is equals to 4. And in the earlier lesson, we learned if the linear scale factor is any number, the area scale factor is the square of that. So it's the same as 2 squared. 2 squared. We can also come and have the volume scale factor. this volume scale factor, you can take the volume of these, 10 centimeters times 4 centimeters, length, width times height, times 6 centimeters. I'll divide by 5 centimeters times 2 centimeters times 3 centimeters. So it's 5 centimeters times 2 centimeters times 3 centimeters. So if I multiply the numerator, 10 times 4, 40, 40 times 6, 240. 240 cubic centimeters divide by 5 times 2, that is 10 times 3, 30. 30 cubic centimeters. Cancel that. I'll get 8. But if you look at 8, this 8 is the same as 2 squared. If you look at it well, it is 2 cubed. It is 2 cubed, meaning volume scale factor is equal to linear scale factor cubed. Should be that one cubed as proved below. So learner, we are going also to prove it below. You can say let the volume of cube P, the volume of cube, let the volume of cube P is equals to 5 centimeters times 2 centimeters times 4 centimeters. So if you work out that, 5 times 2, 10. 10 times 4, 5 times 2, times 3 I mean, sorry. 5 times 2 times 3. If I work out that, I'll get 30 cubic centimeters. But to get the dimensions of Q, you multiply 5 by the linear scale factor. So here let linear scale factor is equal to K. So to get the dimensions of the bigger one, I take this one and I multiply by, I'll take this and I multiply by K. So volume of Q is 5K centimeters times 2K centimeters. Where am I getting 5K? I have to multiply 5 by a linear scale factor to get the dimensions in Q times 3K centimeters. So if I multiply these, I'll get 10K cubed. Not 10K cubed, I'll get 30K cubed centimeters cubed. So volume scale factor, my volume scale factor learner will be equal to 30K cubed centimeters cubed over 30 centimeters cubed. You realize the centimeters cancel with that. 30 cancels with that. So the volume scale factor will be equal to k cubed, where k is the linear scale factor. So learner, if the linear scale factor is given, for example, as 3, the volume scale factor will be 3 cubed, that is 27. If the linear scale factor is given as 4, the volume scale factor will be given as 4 cubed, and that is 64. So with that relationship, it is easy for the learner to calculate the volume of what? You can calculate the volume of the second cube having been given the linear scale factor only, because he'll cube it and he'll know the volume scale factor. He'll know the volume scale factor. So at that juncture, learner, just go through getting again through how we got to that. 1, these were 2 similar cuboids. There are 2 similar cuboids because we've been talking about similarity and enlargement. So the linear scale factor is gotten by getting the ratios of the corresponding sides. It is 2. Area scale factor, I take the corresponding planes, I divide, and I get 4, which is the same as 2 squared, meaning that area scale factor, as we proved in the other lesson, area scale factor is equal to linear scale factor squared. We come to volume and we get it is 2 cubed. And we even prove it further by inserting here a k, a linear scale factor, to get that. And finally, we arrive at our proof. How can that help you? If they have given you a linear scale factor of these, of transforming these to these, and you know this volume, you multiply by the volume scale factor to get the volume of the bigger cubed. So for the assignment, learner, for that assignment, we have learner for the assignment, it is from Mathematics for Kenya Schools by Patel, page 100, exercise 7.3, number 8 and number 9. For the learners who do not know that textbook, there it is. Go to that page, you'll get that work that will give you, sharpen your skills on volume scale factor. So thank you for your audience, and let's meet healthily in the next lesson. Bye.